Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 13 section and midpoint formula. We will be studying section formula with examples and solve many questions from exercise 13a. Are you all ready? Be ready with your pen and papers. We will study together. Let us see what section formula is. To find the coordinates of a point which divides a line segment joining two given points in a given ratio. Section formula is to determine the coordinates of point which divides a line joining the 2 points in a given ratio. If we consider 2 points A and B. Let the point A be of coordinates x1, y1 and point B of coordinates x2, y2. When I join these 2 points using a straight line and take a point P, I am considering a point P. What does this point P do? P divides the line AB in a given ratio. Here we have AP and BP. Yes. Let us take the length AP as some M1 and this PB as M2. The ratio in which the line AB is divided by point P is M1 is to M2. Length AP is M1 and length BP is M2. We will take the coordinates of point P as xy. We don't know what x and y are. Using the section formula, we can find what x and y are. Okay. X will be equal to m1 x2 plus m2 x1 divided by m1 plus m2. And y is equal to, y coordinate is equal to m1 y2 plus m2 y1 divided by m1 plus m2. If you study these two formulas, you can solve every question from this chapter. Now you will be having a doubt, where did this formula come from? Yes, I will be explaining it. Now you know, if the ratio is given and the coordinates of A and B are known, you can find the coordinates of P. P, X, Y can be determined. Similarly, if coordinates of A, B are given and the coordinates of point P is known, in that case we can find this ratio M1, M2. Okay. We discussed the section formula for a point P which divides a line joining A and B in the ratio M1 is to M2 is given by Pxy. X is equal to M1x2 plus M2x1 divided by M1 plus M2 and Y is equal to M1y2 plus M2y1 divided by M1 plus M2. Now let us see how we get this X and Y. Here I have taken the x-axis and y-axis. We have a point A, let the coordinates of A be x1, y1. And that of B is x2, y2. Joining A and B, we get a straight line. Now consider a point P of coordinates xy, which divides a line joining AB in a ratio m1 is to m2. So this distance AP will be equal to m1 and this distance PB will be equal to m2. Now, I am drawing perpendicular from point A to the x-axis, P to x-axis and B to x-axis. Okay. The distance it travels along the x-axis. Here we have x1 distance. Yes. Point A is at x1 distance from the origin. This distance, point P is at x distance from the origin along the x-axis. And point B is at x2 distance from the x-axis, along the x-axis from the origin. Similarly, we will draw perpendiculars from points to the y-axis. This distance along y-axis is y1, this distance along y-axis is y and this distance along y-axis is y2. Now, I am drawing a straight line perpendicular. This is 90 degree. Yes, this angle is 90 degree. Here also we get 90 degree. Now, consider triangle AP. Let us name this as Q and this as R. APQ. And triangle ABR. ABR. What do you think? These two triangles have a common angle. This angle A is common to both the triangles. Then one angle is 90 degree for both the triangles. Yes. What about these angles? These two angles. When you check these two angles, here we have a straight line perpendicular to the x-axis. This is also a straight line perpendicular to x-axis. And then this is a transversal that passes through both these parallel lines. So when a transversal passes through parallel lines, corresponding angles are equal. Therefore, here this angle P and angle B are equal. Which means when you consider triangle APQ and ABR, they are similar triangles. Yes, they are similar triangles. For similar triangles, corresponding parts are equal. Here, AQ by AP, the ratio of the corresponding parts. Let us take, here we have AQ and for this bigger triangle we have AR. AQ by AR will be equal to this side, that is the side which is opposite to right angles, AP and AB. AP by AB, the ratio of AP by AB, and the third PQ BR. PQ by BR. These ratios are equal, they are the corresponding sides. Now, AQ by AR. What is AQ? This is AQ. This distance is x and this distance is x1, which means we can write this part will be x minus x1, right? We need AQ. AQ is x minus x1. What about AR? This is AR. Here the total distance is x2 and this part is x1, which means this distance will be equal to x2 minus x1. AR is x2 minus x1 equal to. Now, AP by AB. What is AP? This part is AP. Here we have AP is of length M1. M1 divided by AB is M1 plus M2. M1 plus M2 equal to. What is PQ? Here we have PQ. This total length is Y and this part is Y1. Therefore, we get PQ equal to Y minus Y1 divided by BR. BR. This total length is Y2 and this part is Y1. So, you will be getting this part as Y2 minus Y1. Y2 minus Y1. Okay. Now, just check this. I am taking the first two parts. These two parts I am taking, that is x minus x1 divided by x2 minus x1 is equal to m1 divided by m1 plus m2. On cross multiplying, we get x minus x1 is equal to m1 into x2 minus x1 divided by m1 plus m2. We need x. So, keeping x on one side and taking all other terms to the opposite side, we get x is equal to m1 x2, removing the brackets and multiplying, minus m1 x1 divided by m1 plus m2. And taking this minus x1 to the opposite side, it becomes plus x1. Now, we can take the LCM. Here in the denominator we have m1 plus m2. Here it is 1. Therefore, x is equal to m1 plus m2 numerator m1 x2 then minus m1 x1 we have to multiply m1 plus m2 and x1. We get plus m1 x1 then plus m2 x1. This minus m1 x1 and m1 x1 can be cancelled. That is x is equal to m1 x2 plus m2 x1 divided by m1 plus m2. Understood how we got this x coordinate? Now to get y coordinate, what you have to do is take these two parts and the same process. Taking these two parts, cross multiplying, taking y on one side and all other terms on the other side, taking the LCM, after which you will be getting a similar term, cancelling, we get y is equal to m1 y2 plus m2 y1 divided by m1 plus m2. These are the coordinates of the point which divides the line joining AB in the ratio m1 m2. Got it? Understood how we can derive the x and y coordinates of the point using which we get the section formula. Clear? Now let us solve some examples. Consider this example. Find the coordinates of point P which divides the join of A 4 minus 5 and B 6 3 in the ratio 2:5. Here let us consider point A 4 minus 5 and point B 6, 3. So this line which joins A and B is divided in the ratio 2:5 at some point. Let us consider P. Okay. Let coordinates of point P be x, y. So here the coordinates of point P are x, y. They are divided in the ratio 2:5. 2 parts, 5 parts of AB. Now this 2:5, m1 is to m2 is equal to 2:5, which means m1 is equal to 2 and m2 is equal to 5. Our first point will be taking as x1, y1 and the second point x2, y2. We have a formula, yes, to find the x coordinate. X coordinate x is equal to m1 x2 plus m2 x1 divided by m1 plus m2. Now here what are the values of m1, x2 and x1? We know these values. What is m1? m1 is equal to 2. 2 into x2. Here x2 is equal to 6. 2 into 6 plus m2. m2 is 5. 5 into x1. x1 is equal to 4. 4 divided by m1 plus m2. Here m1 is 2 and m2 is 5. 2 plus 5. What do we get? 2 into 6 is 12 plus 5 into 4, 20 divided by 2 plus 5, 7. That is equal to 32 divided by 7, which is our x value. X value is equal to 32 divided by 7. Now to find y, we have y is equal to m1 y2 plus m2 y1 divided by m1 plus m2. What are the values? Here we have m1 is equal to 2, y2 is 3. 2 into 3 plus m2 y1. m2 is equal to 5 into y1 is equal to minus 5. Minus 5 divided by m1 plus m2. Same thing, 2 plus 5. that is equal to 2 into 3, 6. 5 into minus 5, minus 25. Minus 25 divided by 2 plus 5, 7. Which is equal to 6 minus 25 is minus 19 divided by 7. We got the x coordinate and the y coordinate. X coordinate is equal to 32 divided by 7 and y coordinate is equal to minus 19 divided by 7, which means our point P x comma y is equal to P 32 by 7 comma minus 19 by 7. Coordinates of point P. X coordinate is 32 by 7 and y coordinate is minus 19 by 7. Clear? Next, example 2. In what ratio is the line joining the points 4, 2 and 3 minus 5 divided by the x-axis? Also find the coordinates of the point of intersection. Let us consider the points as A and B. Here A is 4, 2 and B is 3 minus 5. In what ratio is the line joining? This is the line joining of these 2 points divided by the x-axis. Divided by the x-axis means the x-axis we have in x-axis. Every point along x-axis will be having y coordinate or the ordinate equal to 0. Which means for the point we are considering, we'll have point P such that the x coordinate will have some value x, but the y coordinate will be 0. Okay. Here we'll be taking the point P x 0. Now we don't know the ratio in which they are divided. Let ratio be taken as ratio be k is to 1. Okay. We'll be taking the ratio as k is to 1. This part is k and this part is 1. We need to find this ratio and the point of intersection, this point P. Okay. First let us find the ratio. For that, what is given? Here we have the x1, y1 values and the x2, y2 values. This point is xy. We know the y coordinate is equal to 0. And the ratio m1 is to m2 is equal to k is to 1. We have x is equal to, x coordinate is equal to m1 x2 plus m2 x1 divided by m1 plus m2. And the y coordinate, y is equal to m1 y2 plus m2 y1 divided by m1 plus m2. Okay, let's take the y coordinate because x value we don't know. We know the y value. Yes, y is equal to 0. Y is equal to 0 is equal to m1. What is m1 here? K. K into y2. Y2 value is minus 5 into minus 5 plus m2 y1. Here m2 is equal to 1 into y1. Y1 is equal to 2 divided by m1 plus m2. K plus 1. Taking this to the opposite side, 0 into k plus 1 is 0 is equal to k into minus 5 minus 5k plus 2 into 1, 2. Or 5k is equal to 2, from which we have k is equal to 2 divided by 5. We got the value of k. Then what is k divided by 1? K divided by 1 is 2 by 5 divided by 1, which is equal to 2 by 5. K is to 1. The ratio k is to 1 will be equal to 2 is to 5. We got the required ratio. The line connecting A and B is divided by with point P in a ratio 2 is to 5. Now we need to find the coordinate, x coordinate, then we will be getting the point of intersection. Okay, we need this x value. How to find x value? We have a formula. X is equal to m1 x2. Here m1, we got the value of m1, that is 2. x2 is equal to 3 plus m2 x1. 5 into x1 is equal to 4 divided by m1 plus m2. 2 plus 5. That is equal to 2 into 3. 2 into 3 6 plus 5 into 4 20 divided by 2 plus 5 7, which is 26 divided by 7. We got the x coordinate and y coordinate we know is equal to 0, which means the point P, coordinates of point P are 26 by 7 comma 0. This is the point of intersection. Clear? Next, example 3, if P 9a minus 2 comma minus b divides a line segment joining the points a 3a plus 1 comma minus 3 and b 8a comma 5 in the ratio 3:1, find the values of a and b. What are the non-quantities here? We have the point P. P x comma y is equal to P 9a minus 2 comma minus b. Then what else is given? Line segment joining the point A, that is A x1 y1 is equal to A 3a plus 1 comma minus 3 and B x2 y2 is equal to B 8a comma 5 in the ratio 3:1. m1 is to m2 is also given, that is 3:1. We need to find the values of a and b. Using our section formula, we can find the values of a and b. What is x? We have x is equal to m1 x2 plus m2 x1 divided by m1 plus m2. Put the values. What is x here? Here we have x is equal to 9a minus 2. 9a minus 2 is equal to m1. m1 is 3. 3 into x2. Here x2 is equal to 8a plus m2 x1. m2 is 1 and x1 is equal to 3a plus 1 into 3a plus 1 divided by m1 plus m2, that is 3 plus 1. 9a minus 2 is equal to 3 into 8a is 24a plus 1 into 3a plus 1 is 3a plus 1 divided by denominator we have 3 plus 1 4. Cross multiplying, taking this to the opposite side, 4 into 9a minus 2 is equal to 24a plus 3a is 27a plus 1. 4 into 9a, removing the brackets and multiplying, we get 36a minus 4 into 2, 8 is equal to 27a plus 1. Now bringing all the terms containing a to one side and the constants to the opposite side. We get 36a, 27a, when taken to the opposite side it becomes minus 27a. Minus 27a is equal to 1 plus 8. Minus 8 taking to the opposite side it becomes plus 8. 36a minus 27a is 9a is equal to 9, from which we get a is equal to 9 by 9 and that is equal to 1. We got the value of a is equal to 1. We can now find the value of b by taking the y coordinate. Y is equal to m1 by 2 plus m2 y1 divided by m1 plus m2. Now put the values y. Here y is equal to minus b. Minus b is equal to m1 y2. m1 is equal to 3 into y2. Here y2 is 5. m1 y2 plus m2 y1. m2 is 1 into y1 is minus 3 divided by m1 plus m2. 3 plus 1. That is equal to 3 into 5, 15. 1 into minus 3 divided by 4, which is minus b. Okay, from this we can write minus b is equal to 15 minus 3 is 12, 12 divided by 4. What is 12 by 4? 12 by 4 is 3. We got minus b is equal to 3, which implies b is equal to minus 3. We got a is equal to 1 and b is equal to minus 3. Okay. In the question, we were asked to find the values of a and b. To find a, we took the x coordinate, and to find b, we took the y coordinate. Now let us solve questions from exercise 13a. The first problem, calculate the coordinates of point P which divides the line segment joining. First question, a 1, 3 and b 5, 9 in the ratio 1:2. Here what are the given quantities? We have a point A and a point B. The coordinates of point A are 1, 3 and that of B are 5, 9. So this first point is our x1, y1. These points are x2, y2. Okay. So this is a line joining A and B. There is a point that we consider P of coordinates x, y, which divides the line joining AB in the ratio 1:2. 1:2, which means M1:M2 is equal to 1:2. We got the values of M1 and M2. This is a simple question, right? Now you can use the section formula to find what the coordinates x and y are. To find x, x is equal to M1 x2 plus M2 x1 divided by M1 plus M2. Now put the values. X is equal to M1 x2. Here M1 is 1 into x2. x2 is equal to 5 plus M2 x1. M2 is equal to 2 and x1 is equal to 1. 2 into 1 divided by M1 plus M2. 1 plus 2. That is equal to 1 into 5. 5 plus 2 into 1. 2 divided by 1 plus 2. 3. Or 7 divided by 3 is the x coordinate. We got x is equal to 7 by 3. Now, similarly, we can find y. What is y? What is the formula to find y? Here, in place of x2, we will be having y2. In place of x1, we will have y1. M1 y2 plus M2 y1 divided by M1 plus M2. Put the values. M1, here M1 is 1 into y2. y2 is 9 plus M2 y1. Here M2 is equal to 2 and y1 is equal to 3. 2 into 3 divided by M1 plus M2. 1 plus 2. That is equal to 1 into 9, 9 plus 2 into 3, 6 divided by 1 plus 2, 3 equal to 9 plus 6 is 15. 15 by 3 we get 5, which is our y coordinate. Y coordinate is 5. Then the point P x comma y is equal to x coordinate is 7 divided by 3 and the y coordinate is 5. Clear? We got the x coordinate and y coordinate. The point P which divides the line joining A and B in the ratio 1:2 is 7 by 3, 5. Okay. Now the second part, A minus 4, 6 and B 3 minus 5 in the ratio 3:2. Here we have point A minus 4, 6 and point B 3 minus 5. This is the line joining considering a point P of coordinates x comma y, dividing this line in the ratio 3:2. M1 is to M2 is equal to 3:2. Okay. Now taking our section formula, x coordinate x is equal to M1 x2 plus M2 x1 divided by M1 plus M2. Do not directly put the values. First you have to write this formula because it carries some marks. m1 x2. Here what is m1? m1 is 3. 3 into x2 is 3 plus m2 x1. m2 is 2 and x1 is equal to minus 4. Divided by m1 plus m2. 3 plus 2. That is equal to 3 into 3 9. 2 into minus 4 is minus 8 divided by 3 plus 2 which is 5 equal to 1 by 5. X coordinate is equal to 1 by 5. Now we will find the y part. Y is equal to, what is y? m1 y2 plus m2 y1 divided by m1 plus m2. Now put the values. What is m1 here? Here m1 is equal to 3 into y2 is equal to minus 5 plus m2 y1. m2 is 2 into y1 is equal to 6 divided by m1 plus m2. m1 is 3 and m2 is 2. 3 plus 2 which is equal to 3 into minus 5 is minus 15 plus 2 into 6 12 divided by 3 plus 2 5 which is equal to minus 3 divided by 5. Minus 15 plus 12 is minus 3 divided by 5. We got the y coordinate equal to minus 3 by 5. Therefore, point P x comma y. What is point P x comma y? Here we got x is equal to 1 by 5 and y is equal to minus 3 by 5. P 1 by 5 minus 3 by 5. Understood this? Second problem, question 2 of exercise 13a. In what ratio is the line joining 2 minus 3 and 5 comma 6 divided by the x-axis? Divided by x-axis. We know on the x-axis y coordinate will be equal to 0. For any point that belongs to the x-axis will be having an x value but y value will be equal to 0. Here we have point A 2 comma 3 and point B 5 comma 6. This is the line joining A and B. This line joining A and B is divided in some ratio with point P which lies on the x-axis, x comma 0. Okay, let us take this ratio. Let the ratio be k is to 1. Okay, we are taking this ratio as k is to 1. Now we know the y coordinate is equal to 0. Using this y coordinate we can find the value of k, that by which we can find what the ratio is. Here we have, according to section formula, y is equal to m1 y2 plus m2 y1 divided by m1 plus m2. Okay, here this is x1 y1 and this is x2 y2. Put the values. What is y? Y is equal to 0. Consider this point P which is on the x-axis, therefore y coordinate should be 0. 0 is equal to m1. We have taken the ratio m1 is to m2 as k is to 1. Therefore, k is m1 y2. y2 is equal to 6. k into 6 plus m2 y1. m2 is equal to 1 and y1 is equal to minus 3 divided by m1 plus m2. Here m1 is k and m2 is 1. When this k plus 1 is taken to the opposite side, 0 into k plus 1 becomes 0. 0 is equal to k into 6, 6k minus 3. Or we can write 6k is equal to 3, which means k is equal to 3 by 6. 3 by 6 is 1 by 2. Then what is k by 1 ratio? K is to 1 will be 1 by 2 divided by 1, which is 1 by 2. From which we can write k is to 1 is equal to 1 is to 2. This is the required ratio. Required ratio is k is to 1 equal to 1:2. Got it? So, the x-axis divides the line joining A and B in the ratio 1:2. Here they are not asking us to find the x-coordinate. We only need to find the ratio in this question. Okay, and the ratio is 1:2. Understood this problem? Let's move on to the next question. Next, problem 3, question 3 of exercise 13A. In what ratio is the line joining 2, -4 and -3, 6 divided by the y-axis? In the previous question, the line was divided with the x-axis. Here, the line is divided by the y-axis. What about y-axis? In the x-axis, we have y-coordinate equal to 0. When it comes to y-axis, x-coordinate will be 0 and y-coordinate will have a value. Now, the points A and B. A coordinates are 2, -4 and B coordinates -3, 6. These 2 points are joined with a line which is intersected or divided by y-axis. Let us take this point as a point on y-axis P, and the coordinates are 0, y. Okay, 0, y. Now we don't know the ratio. Same procedures that we have done in the previous question. Let the ratio be k is to 1. K is to 1, which means M1 is to M2 is equal to k is to 1. Now what we have to do? In this question, we have the x coordinate equal to 0. This x coordinate will help us find the value of k. By finding the value of k, we can get the ratio. X is equal to M1 x2 plus M2 x1 divided by M1 plus M2. Now put values. What is the value of M1 here? M1 is taken as k. X is 0. 0 is equal to k into x2. x2 is equal to -3. K into -3 plus M2 x1. M2 is 1. x1 is equal to 2. Divided by M1 plus M2. K plus 1. What to do next? Yes, taking this k plus 1 to the opposite side. K plus 1 into 0 becomes 0. 0 is equal to k into -3, -3k plus 1 into 2, 2. Or taking this to the left hand side, negative 3k becomes positive 3k. 3k is equal to 2 or k is equal to 2 by 3. Then what is k by 1? Ratio k is to 1 will be equal to 2 by 3 divided by 1, which is 2 by 3. Therefore, the required ratio k is to 1 is equal to 2 is to 3. 2 is to 3 is the required ratio. Clear? The same steps we have done in the previous question. There it was divided by x-axis. Here it is y-axis. In case of x-axis, y-coordinate will be 0. In case of y-axis, x-coordinate is 0. Only that difference was there. Then substituting the values and finding the value of k. After finding the value of k, we will get the ratio, required ratio M1 is to M2. Next, problem 4, question 5 of exercise 13A. In what ratio does the point A6 divide the join of -4, 3 and 2, 8? Also find the value of A. Here we have 2 points A and B. We are taking A as -4, 3 and B is 2, 8. This is the x1, y1 and this is x2, y2. Joining the line, connecting points A and B. Here a point P divides this line joining of A and B. Point P, the coordinates of point P are given A6. We need to find the ratio in which this point divides the line joining of AB. We don't know the ratio. In that case, we will take, let the ratio be k is to 1. Okay, k is to 1. We have x, y coordinates of point P, which is A6. Now we can use the section formula. If you know the section formula, you can solve any question from this section. X is equal to m1 x2 plus m2 x1 divided by m1 plus m2. We don't know the exact value of x. It is given as a. But we know the value of y. Therefore, we will take y is equal to m1 y2 plus m2 y1 divided by m1 plus m2. Now put the values. Here we have y is equal to 6. 6 is equal to m1 is k into y2. y2 is equal to 8 plus m2 y1. m2 is 1 and y1 is equal to 3 divided by m1 plus m2, that is k plus 1. Taking this k plus 1 to the opposite side, we get 6 into k plus 1 is equal to k into 8, 8k plus 1 into 3, 3. Removing the brackets and multiplying, we get 6k plus 6 into 1, 6 is equal to 8k plus 3. Now taking all the terms containing k to one side and the constants to the opposite side, 6k, 8k becomes minus 8k. 6k minus 8k is equal to 3 minus 6. Plus 6 taken to the opposite side becomes negative. 6k minus 8k is minus 2k is equal to 3 minus 6 is minus 3. Then what is k? K equal to minus 3 divided by minus 2, that is 3 by 2. We got the value of k. Then what is the ratio? K by 1 or k is to 1 is equal to 3 by 2 divided by 1, which is 3 by 2, which means our required ratio k is to 1 is equal to 3 is to 2. Here we are asked to find not just the ratio but also the value of a. We need to find the value of a. How to find the value of a now? What is a? A is the x coordinate of point P which divides the line joining of A and B in the ratio k is to 1, that is 3 is to 2. Therefore, this is the x coordinate. We can use this formula. Substituting in place of x, a, and putting all other values, we can find what a is. A equal to m1 x2. Here m1 is 3 and m2 is 2. 3 into x2. x2 is equal to 2 plus m2 x1. m2 is 2 and x1 is minus 4 divided by m1 plus m2, that is 3 plus 2, which is equal to 3 into 2 6, 2 into minus 4 is minus 8 divided by 3 plus 2 5 equal to 6 minus 8 minus 2 divided by 5. Therefore, the required value of a is minus 2 by 5. We found the ratio which is 3 is to 2 and the value of a is equal to minus 2 divided by 5. Clear? Next, problem 5, question 6 of exercise 13a. In what ratio is the join of 4, 3 and 2 minus 6 divided by the x-axis? Also find the coordinates of the point of intersection. Here we need to find the ratio and the point of intersection. Divided by x-axis. We know along the x-axis every point will have y coordinate equal to 0 and x coordinate will have some x value. Now we have points A and B. Here A is 4, 3. What is B? 2 minus 6 divided by the x-axis. This is the point P which divides the line joining A and B with coordinate x0 in the ratio. We don't know what the ratio is. Therefore, we will be taking, let the ratio be k is to 1. As usual, we will take the ratio as k is to 1 and find the value of k. Just check this. Here, which coordinate will help us find the value of k? X, we don't know the value of x. Here we have the y coordinate 0. So, taking the section formula of y coordinate, y is equal to m1 y2 plus m2 y1 divided by m1 plus m2. Putting values, here m1 is k, y2 is equal to minus 6, y1 is equal to 3 and y is equal to 0. 0 is equal to k into minus 6 plus 1 into y1, y1 is 3 divided by m1 plus m2, k plus 1. What to do next? K plus 1 into 0 is 0, 0 equal to k into minus 6 6k plus 1 into 3 is 3. Then what is the value of k? Taking this minus 6k to the opposite side, plus 6k equal to 3, which implies k is equal to 3 by 6 or 1 by 2. Then what is the required ratio? K by 1 or k is to 1 is equal to 1 by 2 divided by 1. We can write k is to 1. The required ratio k is to 1 is equal to 1 is to 2. We got the ratio. Now we need to find the coordinates of the point of intersection. That is, we need to find the x coordinate. Y coordinate already we know, which is equal to 0. Taking the section formula to find the x coordinate. X is equal to m1 x2 plus m2 x1 divided by m1 plus m2. Put the values. Here m1 we have determined m1 and m2. m1 is to m2. m1 is equal to 1 and m2 is equal to 2. 1 into x2. What is the value of x2? Here this is x2. That is 2 divided by here m1 is 1 into x2 is equal to 2 plus m2 x1. Here m2 is 2 into x1. x1 is equal to 4 divided by m1 plus m2. 1 plus 2. That is equal to 2 into 1 2 plus 2 into 4 8 divided by 1 plus 2 is 3, which is equal to 10 by 3. We got the x coordinate 10 by 3. Therefore, the point P x0 is equal to P 10 by 3 0. This point on x-axis divides the line joining A and B in the ratio 1 is to 2. Okay. First, we are finding the value of k using the y coordinate, which is equal to 0. After finding k, we can get the ratio. Once we get the ratio, you can find the x coordinate. Problem number 6, question 9 of exercise 13a. The line joining the points A minus 3 minus 10 and B minus 2 6 is divided by the point P such that PB by AB is equal to 1 by 5. Find the coordinates of point P. Here the ratio is given. Given ratio PB by AB is equal to 1 by 5. We have 2 points A and B. Coordinates of A are minus 3 minus 10 and that of B are minus 2 6. This is the line joining A and B. A point P divides them in a ratio. What is given? Here when this point P divides, we get two parts, which is PA and this part PB. Okay. And we know PA plus PB will be equal to total AB. AB is divided into two portions with a point P. AP and BP or PA and PB. PA plus PB we get AB. Now here the ratio, consider this ratio. PB is equal to 1 and AB is 5. From this we can find the value of PA. Yes, PA will be equal to AB minus PB. What is AB here? AB is 5. 5 minus PB 1. that is equal to 4, which means PA is equal to 4. Then the ratio PA by PB, which is M1 is to M2, will be equal to 4 by 1. We got the ratio. Now we need to find the coordinates of P. That is, using the section formula, we will find what X and Y are. X is equal to M1 X2 plus M2 X1 divided by M1 plus M2. Put the values here. We have X1, Y1 and this is our X2, Y2. X is equal to M1 X2. M1 is 4 into X2 is equal to minus 2. Minus 2 plus M2 X1. M2 is equal to 1. X1 is equal to minus 3. Divided by M1 plus M2. 4 plus 1. This is M1 is to M2. That is 4 is to 1. X is equal to 4 into minus 2 is minus 8 plus 1 into minus 3 minus 3 divided by 4 plus 1 5, which is equal to minus 8 minus 3 is minus 11 divided by 5. X is equal to minus 11 by 5. Now find Y. Y is equal to M1 Y2 plus M2 Y1 divided by M1 plus M2. Put the values. M1 is equal to 4 into Y2. What is Y2? Y2 is 6 plus M2 Y1. M2 is equal to 1 into Y1 is equal to minus 10. 1 into minus 10 divided by M1 plus M2. M1 is 4 and M2 is 1. 4 plus 1. Y is equal to 4 into 6, 24. 24 minus 10. 24 minus 10 is 14. 14 divided by 5. Therefore, the coordinates of point P are X coordinate we got minus 11 by 5. And what is the Y coordinate? Y coordinate is 14 divided by 5. 14 by 5. Clear? Here you have to remember this thing just by taking the ratio PB by AB. You cannot take this as M1 by M2. We have to check here this PB and what AB is. PB is this part and AB is this whole part. We need to find what PA is. After finding PA, we have to take the ratio PA by PB. Only PA by PB can be written as M1 by M2. If you take PB by PA as M1 by M2, that is also wrong. Okay. Remember this thing. Only PA, that is the first part by second part. You can take as M1 by M2. Clear? Next, problem 7, question 10 of exercise 13A. P is a point on the line joining A 4, 3 and B minus 2, 6 such that 5AP is equal to 2BP. Find the coordinates of point P. We have a point A and a point B. Coordinates of A are given 4, 3 and that of B are minus 2, 6. Joining these 2 points, we get a line. It is divided by a point P. When this division is done, we get 2 parts, AP and BP. This is AP and this is BP. Given that 5 times AP is equal to 2 times BP. From this we can find the ratio. That is AP divided by taking this BP to the opposite side. AP by BP. What is AP by BP? Here we have 2. Taking this 5 to the opposite side divided by 5. Now this is the ratio in which the point P divides a line connecting A and B. Yes? Correct? Okay. Therefore, we will have the ratio M1 is to M2 is equal to 2 is to 5. Now we need to find the coordinates of P, x and y coordinates of P. Let us take the coordinates as x and y. We have m1, m2. This is our x1, y1 and this is x2, y2. Now we can easily, using the section formula, find what x and y are. X is equal to m1 x2 plus m2 x1 divided by m1 plus m2. m1 x2. Put the values here. m1 is equal to 2 into x2. x2 is equal to minus 2 plus m2 x1. Here m2 is equal to 5 into x1 is equal to 4 divided by m1 plus m2, that is 2 plus 5. X is equal to 2 into minus 2 minus 4 plus 5 into 4 is 20 divided by 2 plus 5, 7. That is equal to 20 minus 4. 20 minus 4 is 16 divided by 7. Therefore, the x coordinate is equal to 16 by 7. Similarly, we can find the y coordinate. Y is equal to m1 y2 plus m2 y1 divided by m1 plus m2. Now, put the values. What is m1 here? m1 is 2 and m2 is equal to 5. 2 into y2. y2 is 6. 6 plus m2 y1. m2 is 5 into y1 is equal to 3 divided by m1 plus m2. Here m1 is equal to 2 and m2 is equal to 5. That is 2 plus 5. Therefore, y is equal to 2 into 6, 12 plus 5 into 3 is 15 divided by 2 plus 5, 7, which is equal to 12 plus 15 is 27 divided by 7. We got the y coordinate and the x coordinate. Therefore, the point P, x, y is equal to P, x 16 by 7, 27 divided by 7. This is the point P. Got it? Let's move on to the next problem. Here we have the last problem for today, problem 8, question 11 of exercise 13A. Calculate the ratio in which the line joining the points minus 3, minus 1 and 5, 7 is divided by the line x is equal to 2. Also find the coordinates of the points of intersection. Clear? Is the question clear? We have solved many questions, but here it is given the line x is equal to 2. Where does the line x is equal to 2 come? Here we have the x-axis and y-axis. This is the point 2. X is equal to 2. And a line which we consider perpendicular to this x-axis passing through 2, all the points which lies on this line will be having x coordinate equal to 2. Y coordinate changes. Here the y coordinate will be 1. Here it will be 2, 3, 4. Here minus 1, minus 2, minus 3, minus 4. But the x coordinate will always remain 2. Then we can represent any point which lies on the line x is equal to 2 as 2, y. Only the y coordinate is changing, therefore keep it as y, and the x coordinate is fixed, which is 2. Here we have points A and B, A minus 3, minus 1, B 5, 7. It is divided by this line. Therefore, joining these two points, we get a point P which divides A and B of coordinates 2, y. Now we got this. We don't know the ratio. Therefore, we need to calculate the ratio. Let us take the ratio k is to 1. Let the ratio be k is to 1. Now we got the ratio. We need to find the ratio by finding the value of k. Here, does the x coordinate or the y coordinate using the section formula helps us to find the value of k? x coordinate is known. Therefore, x is equal to m1 x2 plus m2 x1 divided by m1 plus m2. This formula will help us find the value of k. Put k is equal to, put m1 is equal to k and m2 is equal to 1 in this case. Therefore, x value is 2, 2 is equal to m1 is k into x2 is 5 plus what is m2? m2 is equal to 1 into x1 is minus 3 divided by m1 plus m2, that is k plus 1. Now, in previous questions, we used to take this k plus 1 to the opposite side and it becomes 0. Here we do not have 0, here it is 2. Therefore, 2 into k plus 1 is equal to k into 5 is 5k, 1 into minus 3, minus 3. Next, removing brackets and multiplying, we get 2k plus 2 is equal to 5k minus 3. Taking all the k containing terms to one side and the constants to the opposite side, 2k minus 5k is equal to minus 3 minus 2. 2k minus 5k is minus 3k is equal to minus 5. Minus 3 minus 2 is minus 5. And k is equal to minus 5 by minus 3, or that is equal to 5 by 3. Removing the negative signs from the numerator and denominator. We got k. Now what is k is to 1? K is to 1 is the required ratio. K is to 1 is k by 1 and that is equal to 5 by 3. Which means k is to 1 is equal to 5 is to 3. K is to 1 is equal to 5 is to 3. Now what do we need to find? We need to find the point of intersection. We got the ratio. In the point of intersection, we know the x coordinate and we need to find the y coordinate. Y coordinate, using section formula, y is equal to m1 y2 plus m2 y1 divided by m1 plus m2. Here we have m1 is to m2 is equal to, we have found the ratio which is 5 is to 3. Substitute the values. Y is equal to m1 is 5 into y2. y2 is equal to 7 plus m2 y1. m2 is 3 into y1 is minus 1. Minus 1 divided by m1 plus m2. What is m1 plus m2? 5 plus 3. That is equal to 5 into 7, 35 minus 3. 3 into minus 1 is minus 3 divided by 5 plus 3 is 8, which is equal to 35 minus 3, 32 divided by 8, which is 4. Therefore, y is equal to 4. For the point P, x comma y, we get P, x coordinate 4, P, x coordinate 2, y coordinate 4. This is the point of intersection, P 2, 4. Clear? Now we will be able to solve any question using the section formula. Only we need to study or memorize the section formula, that is x and y coordinates, to find x and y coordinates of the point of intersection. X is equal to m1 x2 plus m2 x1 divided by m1 plus m2 and y is equal to m1 y2 plus m2 y1 divided by m1 plus m2. Using this formula, we have solved all the questions that came in this section. Yes? That's all for today. In today's class, we have studied section formula and solved many questions from exercise 13A. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.